the Physical Science Section 3.3 lesson video, and as always, if you'll subscribe to my channel, you'll have all my videos for the whole year. So we're going to talk about phase changes. So a phase change is a reversible physical change. Because remember, a phase change, we're not changing the composition, that occurs when a substance changes from one state of matter to another. So melting, freezing, vaporization, condensation, sublimation, and deposition are 6 common phase changes. Sometimes you'll hear vaporization as evaporation or boiling, but vaporization kind of encompasses all of those. And so depending on whether you're heating it or cooling it, and depending on what state of matter you have, that determines which phase change it would go through. The temperature of a substance does not change during phase change. If you watched one of my previous videos, I was like nailing it into your head that liquids particles are close together, solid particles are moving, they're vibrating. This is another thing I want to nail in your head. During a temperature change, there is not a phase change. Okay, so this right here is called a heating curve for water. So right here would be 0 degrees Celsius. So when we're below 0, we would have solid, we would have ice. And so if I heat my ice, it's going to increase in temperature. So say we're at like negative 20 degrees Celsius. So I heat it, negative 15, negative 10, negative 5, 0. Well, what happens at 0? Well, that's when it's going to start melting. But notice, does temperature change while it's melting? No, it stays at 0 the whole time. Even though we're adding heat, the energy from the heat is being used to change the state of matter, not the temperature. Remember, energy can change forms. So yes, we're still heating it because that's everybody's argument, but we're adding heat. Yes, we are, but that energy is being used to change the state of matter, not increase temperature. So that is going to stay at 0 degrees until all the ice melts. Now we're at 0 degrees and we have liquid water. So if we continue to add heat, the temperature will change again. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 degrees Celsius. Well, what happens to water at 100 degrees Celsius? It boils. But while it's boiling, we're adding heat, but that heat is being used to change it to a gas, not change the temperature. So it's going to stay at 100 degrees Celsius until it boils. And then if you could contain the gas somehow, you could then continue heating the gas from there. So during a phase change, temperature does not change. Everybody wants to say it does, and everybody gets it wrong. So energy is either absorbed, that should say or, surprise, surprise, I have a typo. Energy is either absorbed or released during a phase change. During an endothermic change, what does endo sound like? Coming in. A system absorbs energy. During an exothermic change, exo makes me think exit, a system releases energy to the surroundings. So if something's endothermic, it's going to absorb energy. If something's exothermic, it's going to release energy. Melting. At a solid's melting point, the particles gain enough kinetic energy to overcome the attractions and move from their fixed positions. So remember, solids, they're vibrating. As we heat it, they vibrate faster, 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 and then eventually they can flow and it's a liquid at that point. Any energy gained by the substance after the phase change, because remember, temperature does not change during a phase change, increases the average kinetic energy of the particles, and then the temperature can rise. So once it officially melts, then we can increase the temperature again. Okay, but we've got to get through that phase change before temperature can change. Freezing. At the freezing point of a liquid, the molecules are drawn into an orderly arrangement. Remember, they're already close together in the liquid, they're just random and they're kind of flowing past one another, so they slow down, and then they're in those fixed locations. Any energy removed from the ice after the phase change, because temperature does not change during the phase change, decreases the average kinetic energy and the temperature drops. A phase change in which a substance changes from a liquid into a gas is called vaporization. Vaporization includes boiling and evaporation. The difference is boiling has to happen at the boiling point. It's when the vapor pressure of the substance is equal to external pressure. Evaporation can happen at any temperature. Evaporation takes place at the surface of a liquid and occurs below the boiling point, whereas boiling happens throughout the liquid and occurs at the boiling point. Evaporation is the process that changes a substance from a liquid to a gas at temperatures below the boiling point. The particles at the surface of the liquid that are moving very fast have enough kinetic energy to leave the liquid and become a gas. So evaporation happens very slowly because you have to get the fastest ones to leave and become a gas. And so that takes time. Remember, we talked about how they have an average kinetic energy, but some are moving faster than others. And so those fastest ones, they have to get to the surface and then leave and become a gas before evaporation can take place. Evaporation increases with an increase in temperature or an increase in the surface area of the container. So think about this. If I have a glass of water out in my room and then a glass of water sitting outside on a hot summer day, which one's going to evaporate faster? The glass of water. That made a lot of sense. They are both a glass of water. The glass of water outside on the hot sunny day. Because higher temperature means it's closer to its boiling point, so it's going to evaporate faster. The surface area also makes a difference. If I have it in like a thin test tube versus in a wide petri dish, the petri dish is going to have faster evaporation because remember, evaporation occurs at the surface. On the test tube, there's not a lot of surface. On a petri dish, there is a lot of surface. A vapor is the gaseous phase of a substance that is normally a solid or liquid at room temperature. Vapor pressure is the pressure caused by the collisions of vapor above a liquid and the walls of the container. So there's a difference in a gas and a vapor. A gas is a state of matter, and we call things a gas that are normally that state of matter at room temperature. So the oxygen we breathe is normally a gas, so we call it oxygen gas. However, other things that are not normally gases can be heated to become a gas. So water, I can boil water. And so we don't call it water gas at that point. We call it water vapor because we had to change it from a liquid to make it into a gas. And then vapor pressure is just the pressure caused by the collisions of a vapor above a liquid. So this right here is bromine liquid. And bromine evaporates very quickly. And so you can see this brownish gas above it. The pressure caused by that brownish gas is called the vapor pressure, because it's the pressure of the vapor from the bromine. When the vapor pressure of a liquid equals atmospheric or external pressure, the liquid then boils. So remember, boiling is about those two pressures being equal. When the boiling point is reached, the particles in the liquid have enough kinetic energy to overcome the attractive forces of the neighboring particles, and then they can spread out and become a gas. And boiling happens throughout the liquid, not just at the surface, like evaporation. Condensation. Condensation is the phase change in which a substance changes from a gas or a vapor to a liquid. So think about a glass of ice water. You'll see that water forming on the outside, and we call it condensation. That is water vapor that was in the air that has hit that cold ice water and has cooled down and become a liquid. Sublimation is a phase change in which a substance changes from a solid to a gas or vapor without changing to a liquid first. So this is normal ice, this is dry ice. Normal ice is solid H2O, and when you heat it, it will slowly melt into a liquid water. Dry ice, on the other hand, is solid carbon dioxide, so it's like what we breathe out, but the solid form. If you heat it, it goes directly to a gas form. That's why we call it dry ice. There's no melting, there's no liquid to clean up. Deposition is when a gas or vapor changes directly into a solid without first changing to a liquid. The phase change is called, of course, deposition. So here we have this purple gas, it's iodine. Instead of condensing and forming a liquid when we cool it down, it goes directly to a solid. These are iodine crystals, and they're completely solid. There's no condensation whatsoever. It went directly from a gas to a solid. So here's just kind of a phase diagram that shows all the differences and what's happening between our solid, liquid, and gas. And then this is called a phase diagram, and so this shows each pressure and temperature at which you get a solid, a liquid, and a gas. So like if I know my pressure is 5.11 atm, and I know my temperature is 31.1, I can say, okay, what state of matter am I going to get? Well, here we go, I'm going to get a gas, just like that. So, section assessment, name 6 common phase changes. Well, you have freezing and melting, you have vaporization and condensation, and you have sublimation and deposition. Alright, number 2. What happens to the temperature of a substance during a phase change? What happens? Nothing. The temperature does not change. The temperature does not change. Number 3. How does the energy of a system change during a phase change? Well, during a phase change, since we don't know which one, I can't tell you exactly what's happening, but energy is either absorbed or released. Okay, since they didn't specify which phase change, we don't know, but energy is either absorbed or released. Number 4, what happens to the arrangement of water molecules as water melts and freezes? Well, when water melts, the water molecules become more random, and when it freezes, they become more orderly, but they're close together in both cases, just saying. right, what's the difference between evaporation and boiling? Well, evaporation happens below the boiling point. Boiling happens at the boiling point. Evaporation happens at the surface. The boiling happens throughout the liquid. So there's two differences. And then number 6, explain why sublimation and deposition are classified as physical changes. Well, even though sublimation and deposition are probably the two you'll see the least in your daily lives, going directly from a solid to a gas and a gas to a solid, it is still just a phase change. The composition does not change, and that's what makes it a physical change. The composition does not change. All right, so hopefully you understand how phase changes occur and the energy associated with it a little better.